Let us now look at some specific financial functions, namely NPV and IRR. As you know, NPV stands for net present value and IRR stands for internal rate of return. In terms of the theory for both NPV and IRR, you can refer to the videos on corporate finance topics where we discuss the theory of NPV and IRR in detail. In this session, we are just going to look at how Excel implements these two functions and what kind of inputs need to go to these functions. Let's look at a scenario. You make an investment in year 0 and you are expected to get returns over the next 3 years. Imagine the investment that you have made is 5,000 in the first year, and in subsequent 3 years you are going to get returns of 3,000, 3,000 and 3,000 each. Now if I say I want to calculate the NPV of this value, the first thing you would ask me is what's the discount rate. Let's assume the discount rate is 10%. So if I go from basic theory, I would use the formula to discount a cash flow C in the year I, which I denote by CI. I can use the formula. The present value of that is CI divided by 1 plus R raised to N, where CI is the cash flow in the year I, R is the discount rate, and N, or more specifically I, is the year from the initial date. In this case, if I use that formula, I'll say equal to the cash flow divided by 1 plus the discount rate. I freeze this exponential year. I copy this formula, I get this. So the total present value of all the values including the investment is 2460.56, which is also known as net present value, NPV. What we did was from the basics, but as I said, Excel does provide you an inbuilt formula called as NPV. Let's look at it. Equal to NPV. It says returns the net present value of investment based on discount rate and series of future payments, is negative values, and income positive values, which means it follows the convention. Inflow is positive, outflow is negative. I give the bracket. It first asks me the rate. The rate is this value, discount rate, comma. It will now ask you value, value 1, value 2, value 3. This is the undiscounted cash flow, which is this cash flow. I choose this, I close, and you get a value which is 2236.87. Now you may wonder why, what happened. The reason is when I give the NPV value and I give the cash flow, NPV value by default assumes that whatever is the first cash flow given to it, it discounts that by the first year. In this case, if you see, we had started with this and given the entire cash flow. As a result, in NPV, if you begin with the column C, it will assume that even the column C value needs to be discounted by 1 year. However, as you see here, the cash flow in column C, that is minus 5,000, is happening in the year 0. So it should not be discounted per se. As a result, the correct implementation of NPV is You give the cash flow which needs to be discounted, plus you separately give this, which means only discount this cash flow appropriately by the respective year plus the initial investment, and that is when it matches. So if you see this, both of them match. So while you are using NPV, just be careful. Just because you have a cash flow, don't discount the entire cash flow. You are bound to get the wrong result. So the correct way of NPV is, in the NPV formula, only give that cash flow which needs to be discounted and then give the initial investment. If in the problem statement it is given to you that the initial investment itself happens at the end of the first year or at the end of the year, then giving the entire cash flow makes sense. Else, cash flow which happens right now or the investment which happens right now is not required to be discounted, and hence this implementation. On similar lines, as you know, you can also calculate the IRR. By definition, IRR is that discount rate at which NPV falls to 0, which means I can use two ways of calculating IRR. One, I use the straightforward formula IRR, which is equal to IRR bracket. It tells me, gives me the values. The values are this undiscounted value. Guess is optional, not required. And that's the value of IRR, 36.31. Or there's an alternate method. By using the definition, it is that discount rate at which NPV is 0. So we have calculated NPV here. And if you remember, we have done something called as a goal seek. So you can also calculate IRR using the goal seek option. Let's look at this. So I go to data, go to what if, and goal seek. Here I'll say this is the value I want to set. It's already selected, and this should be set to 0. By changing, this is my discounting rate which I have used. Use this, OK, and you see that this changes. I take it to 2 decimals and that's it, 36.31. Exactly matches with the IRR calculation. So either you can use the IRR formula directly to calculate the IRR, or you can use the discount rate, use goal seek, and then use the definition that NPV is 0 when discount rate is equal to IRR. Mostly whenever we use any kind of cash flows to calculate IRR, we generally use this method. This is just an alternate method in which you can calculate it. Thank you very much.